Hello everyone. In this video, I'll discuss about a transformer, which is a part of alternating currents. So this is how a transformer will be. It is a device used to increase or decrease the voltage in the AC circuits. Device used to increase or decrease voltage in AC circuits. So the basic circuit will be like this. We'll have one circuit called that is a primary circuit. This first part will have primary circuit where we'll connect our AC source. This is called our primary circuit where we'll apply input voltage, and here this number of turns N1, number of turns in the primary, and this is called secondary circuit where we will connect a load resistance. That load resistance across which we will measure our output or any circuit appliance will be connected. So we'll have two coils, and these two coils are not directly connected, but they are wounded on a ferromagnetic core. Same core will be there for both of them. This will be a core generally made up of ferromagnetic material. So this works on, and N2 represents, if suppose we are having a secondary coil, the output voltage will represent with V2. N2 represents number of turns in the secondary. And this transformer works on the principle of mutual inductance. As we connected this to an alternating voltage, primary circuit is connected to an alternating voltage, so that current in this coil continuously changes with respect to time. As current in that coil is continuously changing with respect to time, it will produce a time varying magnetic field, so that magnetic flux linked with that secondary coil continuously changes due to change in current in the primary. So this causes an induced EMF. As that magnetic flux is continuously changing with respect to time, we will get alternating voltage in the output. And if it is an ideal coil, flux linked in the primary is equal to or is same as that of the flux in the secondary. So we can write like this E1, or I can write V1 as we are using V1. V1 is equal to minus N1 into d phi by dt. If N1 number of turns are there, this will be equal to minus N2 into d phi by dt, that is V2. This is in the primary voltage, and this is our secondary voltage what we observe. And from these two, we can say like this: V1 by N1 will be equal to V2 by N2, or from this V1 by V2 will be equal to N1 by N2. So primary to secondary voltage ratio will be equal to primary to secondary turns, and here if n1 is greater than n2, that means number of turns in the primary is greater than number of turns in the secondary, then we'll call that as step down transformer. And if n1 is less than n2, that means number of turns in the secondary is greater than number of turns in the primary, then we'll call that as step up transformer. So we'll have two kinds of transformers. It can be a step down transformer or it can be a step up transformer. If it is an ideal transformer, for an ideal transformer, what is meant by ideal transformer means there is no power loss. If there is no power loss, power in the output will be equal to same as that of the power in the input. So if input power is P1 and output power is P2, input current into input voltage, that will be equal to input output current into output voltage, or from this we can write like this: V1 by V2 is equal to I2 by I1, or that will be equal to, already we know this, N1 by N2. So this is one interesting equation where you will have some good number of numericals based on this. And here you have to remember one key note point. If suppose they gave one terminology called turn ratio or transformer ratio means you have to take number of turns in the secondary to number of turns in the primary, so that will be equal to voltage in the secondary to voltage in the primary, or I1 by I2. Whenever they mentioned a statement called transformer ratio, you have to take that equation like this. And generally no transformer will be ideal. Definitely there will be some power loss because we are using coils, they are made up of copper. So if the transformer is not ideal, non-ideal transformers, means there will be some power loss is observed. It can be due to coil wire or ferromagnetic core. So, and when current passes through a coil wire, it is made up of generally copper, so that we'll call that loss as copper loss. It will observe due to conventional currents. So that power loss we can take like this: I square R if coil resistance is known. This is due to conventional currents. And if it is a ferromagnetic core, as that magnetic field is changing with respect to time, we can observe some eddy currents. So that this loss, we'll call that as, generally that ferromagnetic material will use as iron. So that this current, eddy currents loss, we'll call that as iron loss. We cannot minimize these losses, but we can reduce ferromagnetic core loss by using a laminated core. By laminating the core, we can reduce iron loss. So here our idea is like this: if suppose there is some loss, definitely we have to speak with respect to efficiency. So that efficiency will be like this. That efficiency is defined as output power by input power. Output power is nothing but output current into output voltage by input current into input voltage. So here we should not use this equation. What we already got that V2 by V1 is equal to I1 by I2, we should not use, because there is some loss in this transformer. Then we have to use these equations and we have to solve that questions whatever asked based on this transformers. Okay, that's it for this video. And with this, I'll complete a chapter called alternating current. Just follow my channel. You'll find all 4 videos. I just completed this chapter in 1 hour 30 minutes, which will be very helpful for your NEET as well as JEE mains level preparation. Subscribe and share progressive physics learning profile. Have a great time.